Number one, we're trying to prove something to be false, so something that's not always true. As soon as we can find an example where it's false, we know that we have found our winner. Let's begin with number one, answer choice one. The product of two irrational numbers is irrational. All right, so maybe I'll try pi times pi. Well, I multiply that in my calculator, definitely irrational. Maybe I want to try the square root of a non-perfect square times the square root of another non-perfect square. Try that in my calculator, still irrational. I'm going to try one more case of maybe multiplying the same irrational times the same irrational number. The square root of 5 times the square root of 5 is actually 5. So answer choice 1 is not always true. Number 2 wants us to interpret the equation that we have here. First thing that we should know is that this is linear. It's in y equals mx plus b form, or really the b is out in front because there's our constant. Remember, the constant is always the initial value. The constant, it never changes, the starting point. Let's look for that in each one of our explanations. So y is the total cost. I'm not worried about that. I want to talk about the 40. 40 is the service charge per month. Definitely not, because that means that it could possibly vary. Okay, let's see, $40 is the installation fee. Interesting. I think this might be, this looks pretty good. I'm not going to cross off number 2. An installation fee would be something that you would pay up front, and 3 I'm going to keep for the same reason. I'm also going to get rid of 4 because of the same reason why I got rid of 1. Answer choices 2 and 3 are very similar except for the beginning part, where y is the total cost in number 2 and x is the total cost. Well, if it's a total cost, it would mean that that would equal a whole bunch of calculations. So number 2 is our winner. The easiest way to do question number 3 is graph it and look for the roots, the x-intercepts, and you'll find that if you do that, you should get answer choice 3. But let's prove it mathematically. The first thing that I notice about the quadratic equation, the parabola, is that this can be factored. And the reason why I know this is because all of my answer choices and the correct answer are all integers. So whenever that happens, we can factor. It looks like I can factor out a GCF first, which is nice. That's 4, and I'm left with x squared minus 25. Then I'm going to double check to make sure that I can factor again, or if I can factor again. And indeed I can. That's a difference of 2 perfect squares. So I'm going to create my double skeleton template, parentheses, and x times x would give me my x squared, and I'm looking for 2 numbers that multiply to 25. In this case, it's negative 25, so a positive and a negative 5, and they also had to add to 0. So that's how I know that they are the same number. My last step would be to take each one of my factors and set those all equal to 0. And by doing this, I realize 4 equals 0 doesn't make sense, so I'm not going to even bother with that. But x plus 5 equaling 0, if I move the 5 to the other side, that gives me my root at negative 5. And x minus 5 equals 0, if I move the negative 5 over, I get a positive 5. When you look at question number 4, it's pretty clear that we're going to have to do some one-variable statistics. I think that's the fastest method. I mean, if you look at it, we're talking about the median, the mean, the salary range. If we do the one-variable statistics, it's going to be nice and easy to see all these values. So here's a table of the data that I compiled for question number 4, and as you can see, Number 1, 2, and 4 are all incorrect, but 3 is correct because the range in company 2 is greater than the salary range in company number 1. Some of you may have just looked at these answer choices before doing the one variable statistics and realized that that clearly was the case by looking at the values, but I wanted to show you the most thorough method. So with question 5, there's an easy way and a hard way to do this question. We're going to go with the easy method. So first, graph this. Then look at the table of values. The more difficult way would have been to use substitution, but this is something your calculator does much faster than what we can do by taking all of the x values, the first value in the ordered pair, substituting it in for x, and then seeing what y value you get out. If I look in my table of values, however, I can see that negative 612 is a point, negative 4, negative 2 is a point, 2, 4 is a point, but 3, negative 6 is not. Now if I prove this algebraically to see that answer choice 4 is not a point, I substituted in 3 for my x values and I got a y value of 12, not negative 6. If you weren't being careful with your signs in question number 6, it would cause you to pick the wrong answer. So you need to be really careful to distribute this negative right here. It's a simple substitution. It looks scarier than what it really is. So you're going to put in r of x minus c of x, and that's when the negative gets distributed to both the 300x and the 250. So we need to combine our like terms, and after you combine your like terms, you should end up getting answer choice number 2. Question 7 is pretty straightforward. It's asking which of the points listed below is a solution. So let's identify them on the graph. So the point 7, 0, and then the point 3, 0, the point 0, 7, and then the point negative 3, negative 5. So when we find the solution, my points are a little off just because it's a little difficult to see on here. So when we try to find a solution, we are looking for a point that's in the shaded area of both of the inequalities. That identifies a solution. The trap answer, I would say, if you weren't being careful, would have been this point right here, the point 30, because it is the intersection point. But actually, it's this point right here. So answer choice 1. In question 8, remember the value of the x-intercept is when y is 0. So we could write this in slope-intercept form, graph it, and determine what the x-intercept is that way. Or what I think is much easier to do is put in 0 for y and figure out what x is. So in this case, we get 4x is equal to 40. So x is equal to, if we divide both sides by 4, we get x is equal to 10. So in question number 9, we're talking about Sam and Jeremy, and they have ages that are consecutive odd integers. So what does that mean? Well, let's list out a few examples. So if I have 5, 7, 9, 11, those are all odd integers. So as we can see, we're actually counting by 2's. Our first integer must be odd, though, in order for this to work. So if Jeremy, his age is represented with j, Sam's age must be j plus 2. So we know that their product is 783, and product means multiply. So j times j plus 2 has to equal 783. Now this doesn't look just like one of my answers yet, so what I'm going to do is distribute, and I end up with j squared plus 2j j is equal to the 783, which is answer choice 3. Question 10 is modeling a population of birds, initially 20 birds, that is doubling every 10 years. Initially, that's my y-intercept. So if I look at my y-intercepts, I'm going to eliminate the graph where I don't have a y-intercept at 20. I'm also going to eliminate graph 2 because the bird population is doubling. This graph is decreasing. So now I have a 50-50 shot to get this right. And if something is doubling, that is definitely not a linear relationship. And just to verify, we start at 20 birds, and after 10 years, so right around here, it will double. So if I double 20, that becomes 40. It's right around there. It's a little hard to get it on the graph with the iPad stylus. And then after 20 years, that 40 will double to 80.